Alright, so picking up where we left off, we're crossing two heterozygous parents, right, from the F1 generation, right? So because of the big T, the plants would be tall, right? And because of the big R, they would be round, right? And it's a similar case for the other parent, tall and round. Seeds, good. So now let us put the gametes in, but first we need to know the gametes. So remember, we can apply the formula, which is 2n to the n, to figure out how many gametes we're supposed to get. Alright, n is the number of heterozygous alleles present. So because there's two heterozygous alleles, this is heterozygous, this is heterozygous, it would be 2 to the 2 equal 4 gametes. So we're expecting 4 gametes from this parent and 4 gametes from this parent. Alright, so how do we get the gametes? Remember, these are alleles, so this allele could randomly assort to pair with this allele during meiosis. Right? So what we would get at the end of the day is T R. T can go with that, so that's T R. This little t could go with this big T to give us T R. This little t can go with that little r to give us T R. And clearly, if this parent give us these 4 alleles as expected, then it is then true for the other parent because it's the same genotype. So let's go ahead and put that down. T R T R T R and T R. So now we have 4 gametes from this parent, 4 gametes from that parent. So now through random fertilization, let us see what are the genotypes that we would get for this dihybrid trait or cross. So TR could pair with TR to give us T, 2 big T's and 2 big R's. Alright, and remember we say to put the letters together, put the alleles, similar alleles together. This could pair with that to give us that. This could randomly fertilize with that gamete to give us that. And this could randomly fertilize with this gamete to give us. Good. So you can see we're on a good path here. You can continue the trend and fill in the entire table. And there you have it. So now we have all the possible combinations, and we have a total of 1, 2, 3, 4, 1, 2, 3, 4, 4, 4, 16 gametes. All right. So now let us fill out this side of the sheet where it says how many now would be tall and round. Now remember, in order to be tall and round, you must have a capital T and you must have a capital R. So let us look at that. Capital T, capital T. So we're getting 1, 2, 3, 4, 5, 6, 7. No. I'm wondering. Am I doing it right? No, I'm not doing it right. So remember, it has to be a capital T and a capital R. You can't just look at the T's. Alright, so let's go again. This is 1 because it has capital T, capital R, tall and round, because remember the dominant allele will mask the recessive allele. So this is 1, 2, 3, 4, 5, no, 6, 7, 8, 9. So now we're getting 9 tall and wrinkled. Sorry, tall and round. Let's look at the tall and wrinkled. Alright, tall and wrinkled. So in order to be tall and wrinkled, the organism must carry the big T, capital T, and the little r. Let's see how many do that. Have that. No, 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 no. So we're looking at 1, 2. Did you find it? Did you find it? Tell me if you found it. And 3, right there. So we're looking at 3 tall and wrinkled. Short and round. So in order to be short, the organism must carry the small t and the big R, the capital R. Let's go across. Small t, capital R. Looking, have you found it? You can pause the video and try to find it for yourself. Alright, so small t, capital R. You're correct. 1, 2, 3. So that's 3. Short and wrinkled. In order to be short and wrinkled, the organism must carry a small t and a small r. Let's look. Small t, small r, small t. Remember, you can pause the video to find it for yourself, to challenge yourself. And of course, here we have the only one with small t, small r, small t, small r, which is the pure recessive form. Alright, and that's only one possibility. So what we find happening here from a heterozygous cross and between two parents, or two parents that are heterozygous, will give you a ratio 9 to 3 to 3 to 1 for these traits. Alright, so, and this would be the F2 generation. Alright, so the possibilities can be written in another way. 9 over 16, 3 over 16, 3 over 16, 1 over 16. And you can also express it as a percentage as well. Alright, so this is how you do a dihybrid cross. Go ahead and work on the examples that I've given you from the worksheet, and we will discuss them in class.